You may remember in the previous slide we talked about the use of risk and safety management systems approach. What I'd like to do is to take some of the general principles of safety management theory now, and particularly the work of Jim Reason, and then apply that to fatigue as a hazard in detail. On the slide you will see a principle up here, what we call the defences in depth approach. This is a principle derived originally in the military context, and that was where you would have a number of lines of defence in order to protect a particular asset. In the Jim Reason model, he talks about having multi-layered defensive systems. And what you'll see on the graph there is what we would refer to as an error trajectory, or a series of linked causal events, and you have the potential to block them at each of those 4 or 5 levels. Now, sometimes this has been referred to the Swiss cheese model, and many of you who have a background in occupational health and safety will be aware of it, but some of you may not. The general principle is that you have many ways in which you can prevent an accident from happening. The difficulty is that most organisations try to look for just 1 or 2 ways to prevent an accident. And I can give you a really good example of this. A couple of years ago, I went to see a demonstration at my children's school, and part of the demonstration day was that we got to see the kids working, well, what used to be called woodwork, but now is called design and technology, but the principles are effectively the same. What was very interesting about this particular demonstration was that when we walked into the classroom, it was nothing like the classroom that I'd learnt woodwork in 30 or 40 years before that. If you went into the classroom, and we could take a classic piece of equipment that you would see in a woodworking classroom, there was a benchtop saw. This is the kind of circular saw with a blade that penetrates through a metal table, and then you push a piece of wood through it to cut it. What had changed from my day was that now that blade wasn't just spinning raw, but there was a little cover on it. And it was quite a clever little cover, because as you pushed the piece of wood through the cover, it raised the cover, cut the wood, and then as soon as the wood separated, the cover fell back down again. And this minimised the chances that you could stick your thumbs or your fingers into the blade. But there was even more things there. One of the things that we noticed that the kids, before they could actually use the tabletop saw, had to sign in and use a swipe card. That swipe card knew if they had already achieved competency on how to use it. That is, before the kids could swipe onto the machine and activate it, they had to have completed a course that showed them how to use the saw, they had to answer questions on it, they had to know the general principles on how to use all the safety features of the saw, and if they hadn't done that course, they couldn't actually turn the machine on. But as they say with the Ginsu knives, there's more. Not only was there the mechanical coverings, and there was a requirement to be competent before you turned the saw on, but there was also an increased level of supervision in the workshop. When I'd originally gone to woodwork classes, we would all gather around, the teacher would show us what to do, and then tell us to get on with it, and he would go outside for a cigarette. In this particular case, the teacher would walk around the classroom with a supervisory or assistant supervisory staff member watching the kids working, and interestingly, each of the machines had a series of notices on them showing them what was and what wasn't appropriate behaviour. This is an example of what Jim Reason would call a multi-layered or a defences in depth approach. We have layers of mechanical control, we have layers of competency, we have layers of supervisory control. All of those are working together, and the hope is that even if one of those defensive layers fail, one of the other layers will operate to succeed. Now, one of the challenges with fatigue management is it hasn't traditionally been seen as a multi-level system. And as part of explaining the reasons for that, and most importantly for the advantages of shifting towards a multi-level system, I'd like you to look at the following slide. If you look at this graph, you will see that we have given a stylistic representation of the relationship between what it costs for a control and its relative effectiveness. If you look on the x-axis, you will see that we have varied systematically the effectiveness of a control, going from 0 to just under 100%. And on the y-axis, you can see the relative cost of that control. If you'd like to think about this in practical terms, your typical administrative or procedural controls, which are of some but not complete effectiveness, typically fall on the left-hand side of the curve. And your super duper mechanical controls, which remove most of the likelihood of any accident, are the ones that come to the right-hand side, but they typically come at a significant cost relative to, for example, an administrative control. The key point to understand in an organisation is that you have a choice. You can move to the right, that is, you can take the control that you have in place and try to improve it, but that comes at a cost. On the other hand, if you think back to the last slide, if you have a multi-level control system, then you have the potential to not only improve the effectiveness of an individual control, but you have the opportunity to add additional controls into the system. And this is the magic part of what Jim Reason has talked about. In many cases, introducing multiple levels of control in a system is cheaper and more cost effective than endlessly refining a single control. And let me try and illustrate that with a little bit of maths in the next slide. This graph tries to show you a very simple 3-level system. And then what you can see on the columns is we have manipulated the relative efficacy of each level of control. The best way, if you come across the Jim Reason stuff, is to think about each of the levels of control like a piece of Swiss cheese, and the relative effectiveness of that piece of cheese is proportional to the relative size of the holes to the cheese. So if you have a piece of Swiss cheese that's nearly all cheese and very little holes, that would have a high level of effectiveness, say 80 or 90%. On the other hand, if you have a very low effective control, that is a simple administrative control, it may be more whole than cheese. That is, it may be only 20 to 30% effective. What we've done in this demonstration is to manipulate the level of effectiveness of each of the controls, and we've tried to look at the overall effectiveness of each of the systems, having systematically varied the effectiveness of each of those controls. So if we take the column on the left, we have 3 controls, each of which are 80% effective. That means as the number of potential incidents reaches the first control, it will stop 80% of them. That is, 20% will go through to the next control, at which point 80% of those will be blocked, and then the remaining 20% of that will go through to level 3, where we will block another 80% of them. Let's imagine that there were 1,000 potential events at the top of that event trajectory. At level 1, about 80% of those will be knocked out. So from that original 1,000 potential events, 80% of them have been blocked, so we now only have 200. As they hit the level 2 control, 80% of those 200 remaining events will be eliminated, which takes us down to 40. Again, when it reaches level 3, 80% of those remaining 40 will be eliminated, leaving only 8 of the original 1,000 potential event trajectories. And you'll see there on the column at the bottom, it will show you that 99.2%, that is 8 out of 1,000 events remain, and 99.2% of all of the events have been prevented. Now, where the magic occurs is to look at what happens if I systematically vary the relative effectiveness of each of these levels. So each of the columns represents 3 levels at 80, 60, 40 and 20% effectiveness respectively. So on the right hand side, where we have 3 layers, each of which is 20% effective, we have effectively 3 very porous pieces of cheese, or 3 very simple administrative controls perhaps. And on the left-hand side, where we have 3 80%, they could be the classic engineering hierarchy of controls. Now, the important point to look at here is what is the relative effectiveness of a multi-layer system. If you see where we have 3 layers, each of which is 80% effective, those 3 systems eliminate 99.2% of all of the potential events. That is, the overall system effectiveness is greater than the effectiveness of any of the individual layers. Similarly, when we move to the right, if I take 3 layers, each of which is 60% effective, I still eliminate just under 95% of all of the potential events. And that's 3 layers who are only slightly more cheese than whole. If I move to the right-hand side, in the 3rd column, I have 3 controls, each of which is more whole than cheese. Each of those controls is 40% effective, but they still eliminate nearly 80% of all of the potential events. And if you look in the far right column, where we have 3 very wholly bits of cheese, 3 layers of defence, each of which is only 20% effective, that is, they are 80% air and 20% cheese, we still can block nearly 50% of all of the trajectories. The key point to take from this is that when you are looking at multi-layered control systems, even if the individual layers themselves are not particularly effective, as a system working together, they can be particularly effective. And in many cases, if you recall the slide we talked about previously, the cost of 2 or 3 low-cost controls, that is things around the 40 or 50% rate, can actually be much cheaper than trying to find a single control in the 90 to 100% range. The implications of this are profound from a fatigue management perspective. If you think about it, what is it that most organisations have traditionally used to manage fatigue-related risk? What is the single control that they have focused on? And as you will correctly identify, it's the roster. The problem in many organisations, we have moved to the far right of that curve. That is, for our roster to significantly reduce risk more, the cost, that is the marginal cost, the increase in cost to achieve that last 4 or 5% of risk in the system and eliminate it, is actually very expensive. On the other hand, you have the choice of A, further refining an individual control and moving to the very expensive side of the curve, or you can introduce additional controls. And as we'll often say to an organisation, I can give you a roster that will eliminate fatigue-related risk. You work on Tuesdays, you work between 10 and 11 in the morning, and we pay you $200,000 a year. That will effectively eliminate nearly all fatigue in the organisation. So what's the problem? Why don't we just do that for everybody? Well, the answer is really simple. The problem is that for organisations, the cost associated with continuing to refine the roster either reduces income or reduces operational effectiveness in a way that, for most people, there is a gut feeling that the cost of the increased safety isn't a good deal. That is, the loss of income or the loss of operational flexibility costs us more than the relative improvement in safety. I think in many organisations, the challenge is to get people to stop thinking about the roster and to work out what else you got. What other additional controls can we put in place that will enable the organisation to significantly reduce risk, but by introducing additional controls that can be relatively inexpensive. For example, if you look back to that curve we showed you before and you want to move from a cost effectiveness of 90% to 100%, that costs a lot. If you want to go halfway up that curve from 90 to 95%, it'll cost you about 1,000 units. On the other hand, if you introduced a second control that was 50% effective, that would only cost you a few hundred units. Once you understand this principle that as you try to refine a control, you reach a point of diminishing returns, and that's the point at which you need to introduce additional controls, you will understand how fatigue management at a multi-level system works, and most importantly, why you don't necessarily need to have perfect controls, you just need to have more controls.